the idea, of course, of the pseudo inverse. The word pseudo is in there, so no one's deceived. It's not an actual inverse. Oh, if the matrix is square and has an inverse, of course, then if A inverse exists, which requires everybody remembers, it requires the matrix to be square, because I mean inverse on both sides, and it requires rank n, full rank, then the inverse will exist. You can check it. MATLAB would check it by computing the pivots in elimination and finding n pivots. So if A inverse exists, which means A times A inverse and A inverse times A both give I, then A plus is A inverse, of course. The pseudo-inverse is the inverse when there is one. But I'm thinking about cases where either the matrix is rectangular or it has zero eigenvalues. It could be square, but it has a null space other than just the zero vector. In other words, the columns are dependent. What can we do then about inverting it? We can't literally invert it. If A has a null space, then when I multiply by a vector x in that null space, AX will be 0. And when I multiply by A inverse, still 0. That can't change the 0. So if there's an x in the null space, then this can't happen. But so we just do the best we can. And that's what the pseudo